All right, in this video, I am going to explain why when we're dividing decimals, do we do that little loopy thing with the decimals? And the teachers say, well, if you got to move the decimal to the back on the outside number, which means you have to move the decimal on the inside the same number of places, and it's a mess. So let's just explain why all of that makes sense. So let's get started with this. And what we're going to do is we're going to start with something super simple and logical. Why do we do that decimal thingy thing? Okay, so let's start with already I am goofing up because I forgot to turn off the dot thingy thing. Okay, so here we go. So let's start with 6 divided by 2. Obviously, what's 6 divided by 2? 6 divided by 2 is 3. So then teachers, what we're going to do is we're going to ask our students, okay, then what is 60 divided by 20? I'll bet you dollars to donuts that the most common answer for 60 divided by 20 is going to be 30. So parents and teachers, right here, you do not just say, students, what do you mean it's 30? No way. Just let them figure it out. For example, if we know that 6 divided by 2 is equal to 3 because 2 times 3 is 6. Or maybe if we take 6 and put them into clumps of 2, we can make like this. If we take 6 dots, 1, 2, 3, 4, 5, 6, and put them in groups of 2, then we can see that the answer is 3. So when students see 60 divided by 20 and they're like, it's 30. We'll let the students figure it out, and eventually they will discover that, lo and behold, 60 divided by 20 is 3. Now, I had some students think of it this way. They drew some base 10 sticks, 1, 2, 3, 4, 5, 6, and each of those sticks represented a 10. And the student said, well, I want to know how many 20s are there in 60. And he did this. And he said, look at that. There's 3 20s inside 60. And then parents and teachers, we're going to do one more step. We're going to say, well, what's 600 divided by 200? And again, we're going to let students think about it. And eventually we need them to get to the answer of 3 on their own. Do not tell them that the answer is 3. Let them figure it out. So now, by the way, this is what another student did today. This is all today. He made hundreds like that, and then he recognized, oh, look at that. There's 200, there's 200, and there's 200. So our answer is 3. All right, so now, once we've got that, and we're recognizing that it sure seems like the answer is always 3, oopsies, we want students to start to recognize that when we went from here to here, we multiplied by 10, which means we also went from 2 to 20 and multiplied by 10. That's the relationship. And I'm going to kind of squeeze in this, move these equal signs a little bit so I can kind of do a little bit of writing here. And then we want students to notice that to go from 6 to 600, we multiply by 100. And that to go from 2 to 200, we multiplied by 100. So what we want students to start to recognize is that whenever we multiply one of these numbers by a value, as long as we multiply that second number by the same value, we're going to get the same answer. The problem itself might look different. For example, 60 divided by 20 looks different than 6 divided by 2. But because both of those values were multiplied by 10, that's how we got to 60 divided by 20, the answer itself stays the same. Now, why is this important? Well, we're going to think about this as the quotative approach, which is how many groups of 2 live in 6? How many groups of 20 live in 60? In fact, that's what these students did over here. How many groups of 200 live in 600? That's important that we think about that, because now when I do the problem, let's say 5.76 divided by 0.4. Now what we're asking is how many groups of 4/10 live in 5.76. So how many groups of 0.4? How do you circle a 0.4? Up here, it was pretty easy to see. How do we circle a 2? We knew how to circle a 2. How do we circle a 20? It's right here. We don't really know. It's not quite as intuitive. How do we circle a group of 0.4? So what we're going to do is that we're going to use this new skill that we learned. That we don't know how to circle groups of 0.4, but if I multiply this by 10, I get 4. And if I multiply this number by 10, I get 57.6. I get a brand new problem, but we know it's going to give us the exact same answer as the original problem right here. The difference, however, is we know how to make groups of 4. We know how to circle groups of 4. We do not know how to circle groups of 4 tens. That's a little bit trickier. So now it's just up to us to model that problem. Now I'm going to use dots, but there's a whole host of ways we could model this. And so we're going to now model 57.6. All right, so let's do that. So 57.6 is going to look like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. And now we are ready to start circling our groups of 4 because we know how to do that. So let's do it. So we're going to circle a group of 4. Uh-oh, I have that one extra dot left over that I cannot continue circling groups of 4, so I'm going to exchange him for 10 in the ones place. Now I've got a ton of dots in the ones place, plenty of dots to circle groups of 4. So let's see, we can do, there's a group of 4, there's a group of 4, there's a group of 4, and then we have one last group of 4 with a single dot left over. So this single dot left over is going to get exchanged for 10 in the tenths column. And now I have plenty of dots to make my groups of 4. There's a group of 4, there's a group of 4, there's a group of 4, and there's a group of 4. And we can see our answer is one group in the tens place, four groups in the ones place, and 4 in the tens place, and our decimal lives right here, separating the whole numbers from the decimal. So the answer is 14.4. Now, that's 14.4 is the answer here, 14.4. Now we need to help our students recognize that, well, even though these two problems look different, since we multiplied both of those values by 10, that both problems are going to give us the answer of 14.4. Holy moly. So what's the big conversation? First conversation is for students to recognize that when both numbers are multiplied by 10, while the problem itself looks different, it's going to give us the exact same answer as the original. All right, that's the first step that students have to learn to really believe. Then here we recognize that we did not know how to circle groups of 4 tenths. So we multiplied both of these numbers by 10 to give us a new problem that we did know how to model. That answer is 14.4, which means the original problem is also the answer of 14.4. So let's take one last example at that. Now I'm going to go super duper fast. So if you need to, just pause the video, rewind the video, all that sort of stuff. So 0.05. We don't know how to make groups of 0.05. So what we're going to do is we are going to, we are going to multiply both of these values by 100, because that's going to make this second number, the divisor, 5. And that's going to make the first number, the dividend, it's going to be 565. Now, 565 divided by 5, we know how to do. We know how to make groups of 5 and circle groups of 5. We don't know how to make groups of 500s. That's a little trickier. So, but nonetheless, let's do kind of like the long division technique here. So 565, and I'm going to do a little bit different way. How many groups of 5 are in our hundreds? Well, we can make one group of 5 with 0 left over. We could drop the 6, but we don't need to. How many groups of 5 can we make in that, out of that 6 tens that are right there? Well, we can only make one group of 5. So that gives us 1 dot left over. We're going to exchange that dot, and that's going to give us 15. It's going to give us 10 new dots in addition to the 5 dots that are already sitting there. We now have 15 dots. And how many groups of 5 can we make? Well, we can make 3 groups of 5, and that's the answer of 113. Since that second problem, the answer there is 113. That automatically means the original problem, the answer is also 113. Woo! That was 12 minutes of a full long speech, teachers, that we want you to guide students through so that this idea of multiplying both of the numbers in a division problem to change what the number looks like makes sense. That while the problem changes the way it looks and is easier for us to solve, it gives us the exact same answer as the original problem. And that's the whole key right there. Woo! That was worth it.